Hello, and welcome to this session on using the graph feature of Oracle Database. I am Melly Annamalai. I'm a product manager with the Graph Technologies team at Oracle. And today I will be talking about the graph features and specifically focusing on the Graph Studio feature of Autonomous Database. Here's our standard safe harbor statement. And now let me get started. So graph analytics is a hot topic these days because graphs enable you to get new insights into your data. When you represent your data as a graph, that is, you represent your data entities as vertices in your graph and any relationship between them as edges in the graph, you have the ability to apply graph algorithms, run graph queries, and so on, giving you new insights into your data that is not easily available with other technologies. So for folks who are not familiar with graphs, here's a quick primer on what's a graph. A graph is just a different way of modeling your data. As I was saying, you can represent your data entities as vertices in your graph and any relationship between them as edges. For example, you see on the right here, I have a set of vertices representing customers and a set of vertices representing products. And the relationship between them is that a customer bought this product and that becomes an edge in this graph. On the left, I have an example of a bank and customers in the bank. Customers have accounts. They could be savings accounts, they could be investment accounts, and all of these become vertices in the graph. And every time there's a cash transfer between these accounts, that becomes an edge. So you can see that you can create a graph from almost virtually any data set because there is some relationship between data entities, and you can take that and represent that as an edge. And in the property graph data model, you can have properties associated with your vertices. Like here you have the bank customers with name, address, and email properties, or you can have properties associated with your edges as well. So why are people interested in graphs? Why is this a hot topic? What kind of operations can you do when you represent your data as a graph? So when you represent your data as a graph, you can do many different kinds of queries. For example, you can, let me start with the path example. So looking at the bank example I was just explaining just now, when you have your account holders as vertices and cash transfer relationships represented as edges, so let's say Melly transfers some money to Jean, that becomes an edge in the graph. But there might not be a direct connection between, let's say, Melly and John. But they're made by an indirect connection, that is, Melly has transferred money to Jean, Jean has transferred money to Maria, Maria has transferred money to John. So that's an indirect connection between Melly and John. So to identify such connections, you can use a graph query to see whether there is a path between the vertices Melly and John. And this can be a fixed length path, it can be a variable length path, and we'll see some examples later in this session. And you can find cycles. So it might not be a path that you're looking for, it might be a closed loop cycle that you start with a vertex and end back with the same vertex. So you can find such patterns in your graph or any other specific patterns. And then in the graph analytics side of things, there are all kinds of interesting things you can do with your graphs. You can apply an algorithm on the graph to detect communities. These are highly connected subgraphs within your graph. You can find out important nodes in your graph, which are the highly connected nodes and which are the nodes that are connected to these highly connected nodes, like the PageRank algorithm, for example. You can use machine learning algorithms. You can use algorithms to understand the structure of links and so on. So you're basically, when you're doing graph analytics, you're looking at the graph as a whole and analyzing the graph based on the structure of the graph, how the vertices are connected to each other and so on. And that is what enables you to get new insights into your data. So now let us look at the business uses for this, right? When you run these graph analytics and graph pattern queries, what are the insights? What are the business use cases that could benefit from this. Financial services industry folks are very interested in using graphs to identify anomalous patterns in their data. So here again is a customer looking at using a graph to represent their accounts and cash transfer between accounts. And they see here that here's a source account and here's a destination account. And there is a lot of cash transfers happening between these two accounts, but going through a lot of intermediate accounts. So that to them is something that they want to look at more closely. Is money laundering happening, or what is happening here? Why is this cash transfer going through many intermediate accounts? So this is an anomalous pattern that they want to look at more closely. On the right, you have an example of a bill of materials being modeled as a graph to do dependency analysis. Like if somebody wants to change the design of a particular component, which are the other components that are impacted by that? And you can do that by just running a path query to look at all the paths connected to this component that you're looking at to understand all the other components that are dependent on this particular component. And when you're doing network management, graphs are a nice way to detect malicious traffic, because you're not just looking at the IP packets individually, but you're looking at the structure of how the IP packets are being, or you're looking at the sequence of operations that lead to this particular user being compromised. Like a user visits a website, they're redirected to another website and redirected to another website. So the IP packets move in a certain pattern. So you can identify this pattern and then say, once you determine that this is a malicious pattern, you can identify similar patterns elsewhere. And when you're looking at community detection, identifying communities, they have a wide range of use cases. For example, if you have your customers subscribing to a certain product, if some customers in the community leave, others might also leave with them because they're similar customers and they might leave. So it's used for making, it's also used for making product recommendations. If customers like a specific product, then maybe they're all together likely to like some other product as well. So there are many different use cases when you detect communities of users within your graph. So to take advantage of all of this graph analytics and the insights you can get from graphs, what you need to do is know how to create a graph, query a graph, analyze a graph, and visualize a graph. And that's what we will be looking at now. So let me start with creating a graph. So you're likely to have data in tables that you want to use to create a graph with. So let's go back to the bank graph example, where you have a bank accounts table with all the account IDs listed there, and you have a bank transactions table, which captures information about every time there is a transfer between two accounts. So conceptually, every time there is a transfer from account ID 1 to account ID 672, as seen in the bank transactions table, that's an edge in your graph. So you can keep building up your graph this way. You identify the vertices as accounts, and every time there's a cash transfer, you create an edge. So you keep building up your graph this way, and we will see that in the Graph Studio feature, how you can automate creation of this graph. So when you create your graph, it looks something like this. And now you want to be able to query this graph, analyze this graph, and that's how you get your new insights into your data. So let's go into querying graphs. So when you query graphs, you're looking for patterns in your data set. You're looking to see whether there is a connection starting from this particular node here that goes here and comes back here. So this is like a 3-hop cycle. So you're either looking for a 3-hop cycle that starts with account ID 259, or you're looking for you're saying, find me all 3-hop cycles in the graph. That is a pattern in your data set that you want to detect or identify when you're running a graph query, and you can have different kinds of patterns. Here it's a 3-hop path, not a cycle. So when you're running a graph query, you need the ability to specify a pattern, and that's what the property graph query language enables you to do. It's a SQL-like language with the select construct, the from construct, and so on, and other constructs that developers are familiar with. So it's a SQL-like language with the additional ability to specify patterns, and that's what you see here in the match clause. So this is a simple pattern where basically I'm saying select all edges that connect to vertices. Anything in parentheses is a variable representing a vertex, and anything in square brackets is a variable representing an edge. So I'm basically saying here, select all edges that connect these two vertices, and this is a directed edge. Here's again a similar query which says select all edges connecting two vertices, but I'm adding a label here. So I'm saying I want to start with a vertex of type person, and I want to see all the vertices that it is connected to with an edge of type label. Because a graph can have many different kinds of vertices and many different kinds of edges, and you have labels to determine different kinds of edges and different kinds of vertices. And I'm now qualifying the vertex and the edge with a label and saying, find me all edges that are connecting these two vertices where the starting vertex is of type person. And here's a more interesting pattern where I am starting with a vertex A, going to vertex B, going to vertex C, and then going to D and coming going to C and then coming back to A. So this is a 3-hop cycle. So I'm looking to see, this is going to select all 3-hop cycles in my graph. And here's another example where I'm going to say start with a vertex of type person, and have and find me all paths which are 0 or many hops away from vertex of type person that connects to another vertex where the name is Nikita. So I'm starting with a vertex of type person with name Nikita. So I'm qualifying the starting vertex, and I'm saying 0 or more hops away. I'm specifying that as a regular expression that is supported by this language and finding all such paths. So you can see here that PGQL allows you to specify graph patterns while querying your graph. And we can see how this works here. I want to say, find me all 3-hop cycles in a graph. I would submit a query like this, and we'll see how we'll do that in the demo coming up. And this is very useful for folks who want to detect money laundering, as I was saying earlier, and also trying to identify tax evasion. If folks want to evade taxes, then they start moving their money from one account to another, and then it comes back to the source account. And that's when that's why cycles become suspicious. So here, again, is an example of running a PGQL query to detect a path in the graph. So now here I've identified that account 493 is a suspicious account for other reasons. And I want to look at all accounts connected to 493 that are a few hops away, that are 1 to 4 hops away. So, and I'm again using a regular expression to specify 1 to 4 hops away, and this gives me a way to find accounts that are connected to this suspicious account through a transfer relationship. So now let's go into analyzing graphs, which is where you're looking at the entire graph structure and analyzing it to detect these hidden connections. So you see here, the first class of algorithms here is all about detecting communities, which are subgraphs that have more tightly connected vertices and so on. And then you have the ranking group of algorithms, which help you identify which are the important vertices in the graph by looking at, let's say, the number of edges connected to it, or more interestingly, whether it is connected to other important vertices. Like a vertex might not itself have a lot of edges connected to it, but if it's connected to other vertices which have a lot of incoming edges, then that becomes interesting. So that's the PageRank value. So when you run the PageRank algorithm, every vertex gets a PageRank value. You can find paths in a graph, and the shortest path, there are various flavors of that, like Bellman-Fords, Dijkstra's, and so on. And then you can evaluate structures in your graph and more. So our product is available with over 60 pre-built algorithms that you can use, invoke using a simple API call. As you can see here, in the Graph Studio, you can use the Java API call to kind of, and give in the graph as an argument. So so you don't have to write this algorithm. These algorithms are pre-built, and you can, when you run this algorithm, every vertex gets a PageRank value that you can then use in your queries. And here I visualize this by saying that when I captured the screenshot, I said, find me all vertices which have a high PageRank value and give them a bigger circle and color them red. So you can visually see right away which are the important vertices. So, and then when I want to use this vertex to a query, because ask more queries, I can do so. So now that I've seen that 259 has a higher PageRank value, I can now say, find me all cycles and paths that 259 is a part of. So here are all the cycles it is a part of. And here's this a query to find out all the paths that it is a part of. So you can run algorithms, then query based on the results of those algorithms. So you can really use these techniques together to get lots of interesting insights about your data when you represent your data as a graph. So all of these graph features are available with any database that is supported. And for Autonomous Database, we have the Graph Studio feature, which is a fully managed service available with Autonomous Database that has many interesting features, including automated modeling of graphs. And we'll see that in the demo. You'll automatically create a graph from tables that you select in your Autonomous Database. It includes a notebook UI for integrated visualization and so on. So we'll take a look at that in the demo. And here's what I'm going to show. This is the data I'm going to use in the demo. So I have 3 tables I'm going to use to create a graph: the customer table, the movies table, and the customer sales table. So this is like a movie streaming application. So the customer sales table gives me information about which movies a customer has rented. I'm going to use this to make recommendations for my customers, because I want to be able to make good recommendations for my customers, because some customers are at risk and they might be leaving my service. So I want to identify movies that they will like so that they would stay back with the service, and I won't lose them as customers. So my graph is basically going to look like this. You have a set of customers represented as vertices, you have movies represented as vertices, and when a customer rents a movie, that becomes an edge between them. So with that, let me go to the demo. So I'll start this demo by logging into my cloud instance here, because I want to access my Autonomous Database instance and open up Graph Studio there. So I'm logging in here. I am going into my Autonomous Data Warehouse list that I have here. So I'm going to bring up the movie demo database that I created earlier. And then when I click on the Tools tab, I can see that the Graph Studio card is available. And that's my entry into creating and working with graphs. And I'm logging in here as a database user that I've created earlier in this database and enabled for use with graphs. So once I sign into Graph Studio, I'm now able to start creating my graph. So I'm going to start modeling. And as I was saying earlier, I'm going to select the 3 tables, the customer table, the customer sales table, and the movie table. So these are the 3 tables I'm going to use to create a graph. And when I click on Next, the automated modeler identifies which are the vertex tables and which are the edge tables by looking at the foreign key relationships between them and other information. I can look at the source for creating this graph if you want to change anything. If not, I can just go on to the next page. And if everything looks as it should be, I can go ahead and create the graph. And once I create the graph, I can use this notebook that's available, notebook UI that's available to run queries on this graph. So the first query that I'm going to run is a PGQL query, where I take 2 customers and I find the movies that they both have watched. And you get a nice visual representation of this here. You have the 2 customers and the set of movies that they both have watched. So just a graphical representation of the data that I was showing you in tables earlier. And now we can run this query, which is just a simpler query, just finding all movies, some movies from a customer. The same data result is represented differently: radial representation, concentric representation. So you can have different representation for the same data set. And now we come to graph analytics, the really interesting part about graphs. So I'll start by getting a handle for the movie that I have here, for the graph that I have here. And I can see that I have 151,000 vertices and about 18 million edges. And I'm going to run this algorithm called Pum to follow. What this algorithm does is a bunch of things. It basically creates communities of users. It creates communities of users based on which movies they like. And then it finds movies within these communities and makes recommendation for this particular customer I'm looking at. So it's not, so when I'm just looking for two customers, this is straightforward. Any movie that two customers have watched the same set of movies, then one customer is likely to be interested in other movies the other customer has seen. But when looking at an entire community, it is interesting because you're looking at the entire link structure, how the movies and customers are related to each other, and then you're making movie recommendations. So I click here to identify the movies that I actually identify two sets of things. One is the set of customers that this customer belongs to, and the set of movie recommendations made based on the community that she belongs to. So when I'm running this query, I can see the other customers that this particular customer belongs to. And now I'm going to run this query to get from the result set the movie titles recommended for this customer. And you can see here that these are all basically Java snippets of code. We're using the Java API part of this feature. So now it lists all of these movies that are recommended for this particular customer, Amal, that I'm looking at. So I'm going to look at Lion King and see whether there is indeed a connection between this movie and this customer. And I do see here that I'm using this PGQL pattern, and I do feel that there are two connections between this movie and this customer. So the algorithm has found this connection. It's not a direct connection, it's a dotted line connection, but the algorithm has found it for me. Looking at the next example here, Lady Bird, again, there's a connection between this movie and this customer. And once again, it's a dotted line connection, not a direct connection. So this is a hidden insight that graphs are able to find for me that I could not find directly from my data set. So going back to my slides here, that brings me basically to the summary of what I wanted to share with you today, that graphs are a very powerful tool in your analytics toolkit. And Graph Studio makes it really easy to get started working with graphs. You can start creating your graphs with tables you have in your database. Again, want to highlight that this graph feature is also available in user-managed, that is on-premises databases and co-managed environments, as long as your Oracle database is 12.2 or higher. Graph Studio, the notebook UI, the automated modeling, and so on, these are available with Graph Studio in the Autonomous Database. And you can get started using graphs by following any one of our Live Labs workshops. And with that, I've come to the Q&A. Any questions? I see some questions in chat. Oh, that's a good question. Can I try this in the Always Free tier? Absolutely. This is available in the Always Free tier. But I should also mention that this Graph Studio is in limited availability right now. It is it's going to move into general availability anytime. So I hope you'll find this in any tenancy you might have. If it's not there in your region right away, it will be there soon. But with that caveat, it is definitely available with Always Free tier. Any other questions? Is it possible to create a graph from any data set? Yes, it did. I was using the bank graph example a lot. I also used the example of customers watching movies. So these are all good examples these are good examples, and any data set pretty much can be used to create a graph from, because any data set has some kind of connection or some relationships between the data entities. Can I use Python to work with graphs? Yes. You can. The Python API is available for on-premises deployment. When it comes to Graph Studio feature in Autonomous Database, it is coming. It's coming. Right now, we have the Java API in Graph Studio, but the Python API is on our roadmap and will be available in the future. Can I create my own graph algorithm? Oh, that's an excellent question. That sounds as though it's coming from someone who's familiar with graphs. And you're right, our framework allows that. So we not only have over 60 pre-built algorithms, we also give you the framework to create your own algorithm or customize any one of the existing algorithms. So if you have your own special IP, you can include that in your graph algorithm. So here's another question. What if I don't have the right foreign key relationships in my table to create a graph? So the automated modeler will look at the foreign key relationships and other information to create the graph. If you don't have that, you can always go with what the modeler provides and what I briefly showed in the demo. You can look at the source statement for creating the graph, and you can make modifications right there. You can say, I want this to be an edge. Or in addition to the edges that the modeler has identified, you can all maybe you do have some foreign key relationships that the modeler uses to identify edges. You can add additional edges, and there you can manually add that in the source code that gives you. So basically, it gets you started with the graph statement, and you can always tweak it or add to it. So it looks like there are, I think we might be done with questions. Thank you very much for attending.